Welcome back to Balvikan Bharati with Avila Sarkar. Now we'll move on to problem number 43 in fluid statistics. So 43 problem says a boat carrying steel balls is floating on the surface of the water in a tank. If the balls are thrown into the tank one by one, how will it affect the level, or rather affect the level of water? Okay, so that means whether it will fall, the level will fall, it will rise, it will be same, or rise and fall. The same four condition, the earlier case also is given. But you will get one answer, so no harm if it is not even said in the question with that. So only this much is enough. Now whatever answer will be there as per the analysis or the mathematics behind that, will give you the exact answer. Okay, so a boat carrying a steel ball. So that means if I say this is in a tank, a boat, I'm just drawing it uniformly, is floating. Okay, this is water, a ball is there inside, or a multiple of ball is there. Let's say there are several ball is there. Okay, I'm assuming these are the ball there. So this must be stable condition. Okay, so these are there, a boat carrying steel balls this is a random only shown. This may not be 5, maybe 4, 5, 1, 2, anything floating on the, maybe more than one, because one by one he said, so at least two ball may be there, one on the surface of the water on the tank. So that means it is on the surface, just like it is floating like that. If the balls are thrown, then after the situation will come, let's say one ball is thrown outside, and I don't know whether it will sink down, that means the level will go up, or it cannot be in the air itself, it will be there inside the it is there on the surface. Then floating means some part at least be there. Okay, so for understanding, it cannot be on the surface. some part has to be there, it is submerged. So then after, whether the boat will go up due to the lesser number of ball or higher number of ball, we don't know. One ball is dropped, there could be the possibility what is the level will go up, down, and what you have to think. Fine. So for the first case, when there are, so if I think that the boat, this is your boat, these are the ball. So if I think there are only, for reducing the complication, whatever be the case, with one ball being dropped, because ball are dropped one by one. So if I keep one ball for understanding, without showing all other balls, because whatever the thing will happen with the one ball after being dropped, the same thing will happen consecutively. So for complication of reducing the complication of the drawing, I am assuming initially there are one ball and that is being dropped. Okay, so this is ball. So now this is a bit easy to understand. So the density accordingly of water, rho W, I am assuming ball is rho, and this is ball and this is boat. Okay, so initially, as it is floating and equilibrium, so the initial equation will be first case, for case 1 rather, what do you say, the boat, weight of the boat plus weight of the ball is equal to the weight of the water that is dispersed. So that is equal to this ball, this is balancing the weight of the, this is weight acting and this is the buoyant force on the upward. This is the ball weight, the boat weight, weight of the ball, weight of the boat, and this is the buoyant force on total assembly, the buoyant force. FB rather, FB I will say, buoyant force. This is the case. So weight of the boat is equal to, let's say this is volume of the boat, okay, volume of the boat into rho of the boat into G. So G, as because in every case it will go off, so I am not writing it again. So volume of the ball into rho of the ball is equal to the water dispersed, I am saying it is V. The volume dispersed by the volume is equivalent to how much it is deep inside into rho of water. This would be the case. Let's say this is V1, volume it is dispersing. Okay. So the first case, this one the first case. Second case, case 2, when the ball is dropped. Okay, so this, the volume dispersed due to the boat. Then second case, volume is not there, so weight of the boat equals to the buoyant force. So weight of the boat is again volume of the boat into the density of the boat. This will be same for this case, and this will be how much, let's say V2 is the volume this case being dispersed into rho. This is the case. So now this is same as this. If I replace this value here, so from 1 and 2 I can write this part instead of this can be written as V2 rho of water, density of water. So that means the ball So if I say from this is the replacing value from 2. Okay, so this is the case. Now this I am running because you understood the drawing. So now in second case I have not shown the ball will there, so this will be something like that. When it is dropped, ball will be there because ball is heavier, so it will come down near. So this will be the case. Okay, remember this. Now what is volume of ball into row of ball equal to V1 minus V2 into row. This will be the case. Now this was V1 is the volume dispersed water, so that volume will give you cross section, the cross section into height, and for second case V2 will give you the cross section into height because V2 is the dispersed water in second case. Understood? So this is the case. Okay, now when ball is dropped inside, so this was the water level dispersed, this V1 minus V2, exactly the V of ball, volume of ball into row of ball divided by row of water. So this is the volume difference. Due to that the rise or fall will decide. Okay, now when ball is dropped, the V ball, that contribution of the ball, this is the contribution in second equation, the contribution due to the ball being dropped only with the boat, due to the boat, V2 is dispersed. Now ball has dispersed how much volume? Ball is dispersed equivalent to the equivalent of ball. So V of ball, the water dispersed in this second case, the contribution for that will be the V of water. This will be the case. I mean to say the ball is dropped, so the volume dispersed of equivalent of V. In second case, the total volume V3, if I say this is V2 plus the ball volume. Understood? So V3 is the second case and V1 is the first case. So if I take the difference, so V3 minus V1, let me take V3 minus V1. What is that? V3 is V2 plus V of ball minus V1. This was the case. V3 is the volume dispersed by the boat itself alone and ball dropped, the whole volume of the ball. So V3 is V2 dispersed of the volume due to the boat plus V1. So now V2 minus V1, or either you can say V ball minus this I am taking as V1 minus V2. So this if I put V ball minus V1 minus V2 is equal to again V ball into row of ball or row of water. Okay, now this will become how much? This, if I take V ball common, equal to 1 minus row of ball by row of water. Now this fraction is what? Now V of row of ball means density of ball is greater than density of water. That's why ball when dropped will go down, it will sink down. It is dropped one by one, so that ball is heavier and it will go into the water. So the row of ball is more than row of water. So what is the ratio? Row of ball by row of water greater than 1. So on other hand, if I say 1 minus this is what? Less than 0, because this is more than, so 1 minus this is less than 0, so this fraction is negative. So whatever volume I am getting, V3 minus V1 is negative. So that means V1 is higher than V3. So first case the disbursement of water is more than V3. So that implies the cross section into height for first case is higher than the cross section into height. Second case height rise. So this is cancelled. So H1 greater than H2. H1 is the height raised for this arrangement for the first case when ball was there. When ball is dropped, the height has reduced. So that means if it is consecutively we are throwing the ball out, the constantly the height of the water will go down. The surface of the water will go down. Okay, this is the height raise. When it is dipped, let's say when this was not there, height may be somewhere here. When this dipped, so height gone high. When ball is thrown, height gone less. So constantly it is going down. So H1 height raised due to this arrangement. When ball dropped, height is less. It is coming down. Height raised is less. This is the height raised. H1 and H2 is the height raised, the surface. I mean to say water filled. Now then after I dip this with the ball, so it is gone high, height raised. When ball is not there, height coming down. So this is the H1 and this was H2. So H1 is more than. So when consecutively ball dropped, this height constantly coming down. So surface, how will the effect on the level of the water? Level of the water will fall. My answer is level of the water will fall. Okay. So moving to the next, this has some similar problem. So I want to discuss. This is somewhat very confusing. So that's why you have to discuss. So 44, I will take this problem. A boat that is not in my part, but somehow this kind of problem also may confuse you. A boat is floating on a river with a passenger, or a man, you can say, with a sailor, you can say. A sailor is there who is sailing the boat on a river, and sailor has drunk water, drunk some water, then what would be the effect on level of water of river? So this is very much hypothetical, because a person, if I even take some water, the effect on because river can be think of a huge, but for the sake of the question, you can concentrate the river is somewhat just like a pool, or you can make it in for the river, instead of that you can write it a pool, and you have to think that way, that the water of the pool is drinkable. This is very much drinkable, it's very clean. So if it is not even mentioned, pool water or the river water, whatever you can say, is drinkable. Okay, this may not be there in the question to confuse you further, but I am writing for understanding. There could be two possibilities, that the person has drunk the water from the pool itself or the river itself, or he has bought some water with him and he has drunk. So what is the case when he has drunk the water from the pool? So this is the this can be compared with a, this is the level, it's a boat. Okay, now this boat initially, when a person is there, that means he is consuming some water, so that water, whatever the weight, it will come through this boat. So initially the boat is empty, so that the weight only of the boat is acting. When along with the man and the boat, I am showing it is, this is the weight of boat plus man. Okay, just keep your sense open to understand this boat is representing man and the boat together. Okay, so there the person has not taken any water. Okay, so this is the water full of pool, the boat is there. Now what is the equation when it is in equilibrium? Weight of the boat will be the equal to the buoyant force acting on it. It is in equilibrium to the boat plus man. This can be written as boat plus man. Okay, so that weight of the boat and man together, we can say this is the rho density. So this is the volume into the density rho 1 is equal to the disbursement, maybe V1 water into rho of W. This is my first equation. And second equation, this can be resembled with this situation when the boat has got some water in it. So that means the person has taken water. So what would be the level situation in this case? Okay, level situation. So whether this has gone high, so this could be, I can say H2, this one can be H1. So whether H1 more than H2 or H2 more than H1, that has to be. In second case, when it is there, the weight of bowl plus man will be there, along with weight of the water taken in is equal to the FB double dash, you can say. The weight of the ball and man and the boat, it is same, so their volume taking as same into rho 1 density, and the water taken in is equal to the volume. Let's say the volume of water taken, I have to take it in V of water, let's say, into rho of water, and this is the volume. Second case is V2 and rho. This is, so this is equal to the this, so I can put this value there, V1 rho W plus VW rho W and V2 rho W. So now everything is, no sorry, this is W, so this everything rho can be cancelled. So ultimately equation is V1 plus VW water is equal to V2. Okay, so volume of water here, what I am getting is V2 minus V1. This is the difference of, what is that? V1 is the volume dispersed when this arrangement was there. V2 is the volume dispersed when this arrangement is there. Okay, now this is equivalent to the water intake. This is the volume of water intake. Now logically, if this water, whatever the reduction, whether if I say this is some positive value, so V2 is more than V1. The volume dispersed in second case is more than V1. Okay, so for that V2 minus V1, the definitely there is a height rise, because this cross section is A. If I multiply it with A, so that will be H1 into A. So A will cancel, H2 is more than H1. This can be established. That means H2, the for second arrangement, when the person, passenger or the sailor has drunk some water, the height of the surface will go high. But this has happened due to this water being taken. Now if this water is taken from the pool itself, so there itself a reduction of the volume from the total volume, because let's say the pool having volume of V earlier. Now the volume for that the increment of the disbursement of water is V1. So this will be the ultimately due to which height is raised. Now V is reduced by VW. This VW is from there, it has put back there. So for VW reduction, in the second case, there will be a height reduction, and that is equal to the cross section into some height, and this V is added there, because whatever volume is increased here, it is the same volume which has been taken from here. So if it is there in here, so means V2 minus V1, whatever the volume is increased here, means V2 volume is increased, is the difference. The disbursement of volume is increased here, and due to that height has raised. I am saying this. So this is nothing but equal to the volume here, it is increased. Here the height has increased. Okay. So I mean to say, just a second, let me put it in a mathematical way. So the height raised is H2 minus H1. This is because due to the A into the height raised is equal to the VW by the cross section. Okay. The volume increased in the second case. Volume increase in the second case is more, so the level will go up if it is taken from the outside. But at the same time, if it is taken from the outside, but V2, this understand, this V, if it is added from the outside, and whatever increment is V2 minus V1. Okay, from V2 minus V1 is increased in the disbursement, but the actual total volume of the water was V, and this volume is increased due to the disbursement of water. This height is increasing, and that is equivalent to the VW. Understand? So now VW is equivalent to the volume dispersed, and the same volume, if I take out from the level, so whatever increment has got due to this difference, the effect due to which the height will raise, the same water I have taken out. So that means height will again come down to the original where H1 is there. This is the difference caused, height is raising. So height H2 minus H1 is causing due to the difference of water V2 minus V1 by the cross section. Okay. Now V2 minus V1 is nothing but VW. So now VW is taken from this. So the reduction of height due to the VW by the A is, let's say H. Let's say it has increased first. Okay. Now this is also equal to VW by A. So this is the effect that height has raised. Then after, I am just taking it as a consecutive facts. So initially let's say that due to that VW effect, height has raised. Now if I take out VW of water, so this will reduce this much. So that means whatever height is reduced by this water, and whatever will reduce due to this water being taken out from the pool is H. So this is definitely the same. So height raised due to the water taken by the passenger would have been H2 minus H1, and that is equal to the VW by the cross section. Okay. Now if I take same water from the intake, the effect of reduction will be the same. So there will be no change in height. So if that water is taken out from the same source, there will be no height difference in the of the water surface. If the water is taken from the outside, which that effect is not, because if I consume the water from outside, this is additional water, so that height difference will be there, this will get. But if the pool itself is taking, so this is causing to height rise, at the same time this reduction in volume will bring it down to the same, because these are the same volume of water is affecting the case. The VW is the water by which the height gain is H2 minus H1, but that VW will reduce the same height because the volume is same and the cross section I am not changing. So the same volume can increase the same height, same volume can decrease the same height if it is being taken out. So in this case, if water, so you have to be very careful how it is given. If said that sailor drunk water from river, if it is to confuse, mostly instead of pool it will be given as river. So river water is drinkable, people drinks the water, so they will not tell you so much of clarity. Rather they will say the passenger has drunk some water and what is the effect, only this much will be the information. So in that case you have to think the water being drunk from the river. Okay, otherwise if he has taken some water in a water bottle and drunk, so there will be no change in the weight. The water is in the container which is being carried in the boat and that drunk by somebody, so the places are changed. Instead of that, there is nothing is happening. So in that case, if the water is not poured from outside of the pool, then also the water taken will not give any effect on the surface. In case the water has the chance of getting from outside, because mostly chance will be, because somebody is in river floating, you will not get a chance to get water from outside. He will take of his own which he is carrying, or from the river water. If it is the river water, then also the surface will not change. If it is taken of its own, which is he is carrying from the initially starting his journey, then also there is no change. So this is a unique problem. Otherwise, if something there is a, you can think if there is a loss of weight for some reason, there will be a change of the level. It's fall or rise, that is depends on the situation. But in this case water is taken, so the effect will be same while it has taken from the river itself. Understood? So this is some unique problem. So I will end, because these are taking longer time to make you understand, so I am not hurrying to skip the concept, rather I am taking much time to explain each and every problem. These are very unique problems, a very conceptual problem. So I will end up here, and the next video I will start from problem number 45. Thank you for now.